This is VINDAL'S Academy. You're welcome to this special class. Let us solve e raised to power x equal to 5x raised to power x. This may look like exponential equation, but it's not as easy as it is. You have to watch till the end to see how I'm going to use a special instrument for finding the solution of this kind of question. If you're watching on Facebook, Instagram, or TikTok, remember that this is not a full video. You can click on the description of this video. There is a link there. It will carry you to the YouTube where you're going to watch the full video. But if you're on YouTube, let's get started. Now we have e raised to power x is given as 5x raised to power x. Now there is something I want you to do to understand, and I'm going to do them here to avoid confusion. So I'm going to say that x raised to power x is something as saying e lim x raised to power x, and this particular x will move to this side. So everything is going to be x raised to power x is equal to e x lim x. So this is something. Let me show you another pattern so that you understand. If I have 5, I can write 5 as e lim 5. If I have x, I can write it as e lim x, in the sense that the pattern is showing that if this cancel this, you have 5 alone, which is equal to this. If this cancel this, you have only x, which is equal to this. If this cancel this, you have only this, which is also equal to this. So I am sure you have understood the pattern. That is one thing I want you to understand. Another thing I want you to understand is here. When you see lim, L and N, it simply means log base E. So if you see lim x, it simply means log x to base E. This is what it is, all right? Now, you have understood one or two instruments are going to apply in the solution of this problem. So let's get started. So for this question, I am going to have e raised to power x equal to 5 dots. Now, instead of writing x raised to power x, I'm going to write it as e x lim x, just like I did here. So after that, I am going to have that. I'm going to, have that e raised to power x equal to 5 dot e raised to power x lim x. So I want to push all e to one side. I'm going to have e raised to power x all over. E x lim x is going to be equal to 5. Good. So this is the third step. Now, if you look at the third step, there is something you understood. That is what I call division law of laws of indices. Look at what the division law says. The division law says if you have a raised to power x all over a raised to power y. Now, the law says if the base are the same and they are dividing, that their powers will subtract. So this is going to be a x raised to power minus y. The same thing here. Since e and this e are the same thing and they are divided, I will subtract their powers. So I will say e raised to power x minus x lim x is going to be equal to 5. So for that reason, I am going to have, let's go to the next slide. So for that reason, this is what I have before I continue. X lim x is equal to 5. So the next thing I'm going to do is to factor out the values of x here. So I'm going to have e raised to power x bracket 1 minus lim x, which is equal to 5. So this particular x and this x are factored out. So the next thing I'm going to do is to, whenever you have something on as a power, to bring it down, you need log. For example, if I have p raised to power x, I can say that this is equal to x log p. Have you seen that? Or I can say that this is the same thing as saying ln x p. Have you seen that? I have brought this in which was up down by introducing this ln or this log. And I'm going to apply that here. But before then, let me tidy off my space. Very important. So what should I do here? Now, since there are things on top, I have to bring them down by introducing log e x bracket 1 minus log x bracket close equal to ln 5. I'm missing it. I'm taking ln of this side. I'm taking ln of this side. So when ln have been introduced, the one on top must fall down to multiply the log itself. So I have x bracket 1 minus ln x, then ln e. You see that? Everything on top has been brought down. It's going to be ln 5. Now, there is something I didn't tell you from the beginning. What I didn't tell you was, I think I did. Maybe you didn't pay attention. I'm sorry for that, please. So what I'm saying is that if you have ln e ln x, this can cancel this. You have only x left. I have said that here, okay? So let us apply it in this problem solving. So this is canceling this. So I have an x bracket 1 minus ln x. You're going to make what? Ln 5. Okay. So when I am there, the best thing is to isolate ln x. So what I'm going to do now is to, I think I'm going to divide both sides by x. So I'm going to have 1 minus ln x is equal to ln 5 divide x. So what I will do is the same thing as saying ln x is equal to 1 minus ln 5 divided by x. So that is making this the subject formula, thus moving it to this side and moving this one to this side. Now, when I have done that, I'm going to take the exponentiation of both sides. So what I will do by that exponentiation is to take e of both sides. I'm going to now say e raised to power 1 minus ln 5 over x is going to be equal to e raised to power ln x. Now, what I did to the both sides, what I did to the left hand side, I did it to the right hand side. So remember, this will always cancel this. So what I'm having left is e raised to power 1 minus ln 5 all over x is equal to x. So now, what do you suggest we do? You can pause the video and try what next to do before I come up with my step. Now, I'm sure you've tried that. So what did you get? Remember one thing, that this is going to be ln e raised to power 1 multiplied by ln minus ln, multiplied by e raised to power minus ln 5 over x. Everything is equal to x. Now, I want to clear this function, but see what I will do. But before that, I want to remind you this property of indices. The law says if you have a raised to power yp, it can be the same thing as saying a raised to power y can come in as the power inside power and p can go outside power. Or it can be saying that p can come inside power and y can go outside the power. So this can be applied, but let me show you how we can apply that here. You need to understand how they work before they can. You can always try, this kind of maths you need to be, practicing often. Now, see what I will do. I will say e dot, this is always power 1. I want to show you what it means. Now, the next thing I'm going to say, I will say e raised to power ln 5 inside. Then what is outside is minus 1 over x, which is equal to x. Now, remember what we have been doing here. Good. This will cancel this, and 5 raised to power 1 over x will be left. So let's go. So I'm going to have that e raised to power 1 dot 5 raised to power minus 1 over x is equal to x. Now, what I'm going to do is to multiply both sides by 5 raised to power 1 over x. So I'm going to have 5 raised to power 1 over x dot e dot 5 raised to power minus 1 over x is equal to 5 raised to power 1 over x dot x. Now, this another law of this and this, they will add together and you have 1 left, because 5 raised to power 1 over x plus minus 1 over x is something like saying 5 raised to power 1 over x minus 1 over x, which is equal to 5 raised to power 0, which is something as 1. So for that reason, I'm going to have e left, because this and this are cancelled to be 1. So the answer is going to be x 5 raised to power 1 over x. Okay, so this is where we are right now. So what I'm going to do right now is to make some substitution. Let me highlight it. So in this substitution, I'm going to say that y is equal to 1 over x. That simply means that x is equal to 1 over y. Now, I am sure you may know where I'm driving to. I'm going to hang you there. I'm going to give you the hook and let's keep moving. If you enjoy mathematics, maybe let's keep moving. So that simply means I'm going to rewrite this. So that simply means I have e multiplied by, okay, no, e is going to be equal to, when I have x here there, what is x? Well, x is 1 over y, so I'm going to have 1 over y multiplied by 5 raised to power. When I have 1 over x, I will call it y, so this is y. The next thing I'm going to do is to multiply both sides by y for a reason. So let me go back to yellow. So I'm going to have e multiplied by y is equal to y multiplied by 1 over y, 5 raised to power y. This, we cancel this, I have that ey is equal to 5 raised to power y. Now, I think that is where we are right now. So the next thing I'm going to do is to express this in exponential form. Remember what I mean by expressing it in exponential form. So what I will do is this. Let me show you. Okay, so let me not go back. Look at what I'm going to do. I'm going to say that I'm going to have that e ln 5 raised to power y. Remember that the same thing, because if this cancel this, you still have 5 raised to power y. Okay? So what I will do is I will say y dot e, which is something as ey, is going to be something as e raised to power ln 5 raised to power y, which is going to be the sentence as e raised to power y ln 5. So it simply means, according to the property of log, bringing this to multiply the log, which is under power law. So let's move to the next. Let me go back to my favorite white. So at that point, I am going to look at what we have before we continue. We have y dot e is equal to e raised to power y ln 5. This is where we left off. Okay, so I'm going to divide both sides by e. So say this divided by e and this divided by e. So this is going to be y is equal to e raised to power y ln 5 minus 1. So in order to, to tidy up things, I'm going to raise all of them to power of minus 1. It's the same thing. So I will say y raised to power minus 1, which is equal to e raised to power y ln 5 minus 1, all raised to power minus 1. So multiplying, raising the both of them to minus 1. Simple. So this is going to be 1 over y, which is same thing as saying e raised to power minus y ln 5 plus 1. Now remember, if I have x raised to power 2 plus y, it's something as saying x raised to power 2 times x raised to power y. So I will apply it in this one. I'm going to have 1 over y is going to be equal to e raised to power minus y ln 5 times e raised to power 1. So if I get to this point, what should I do next? I think the best thing to do now is to, clear the fraction, because this is what we have 1 over y is equal to e dot e raised to power minus y ln 5. So if I cross multiply, I have, oh my God, I hate that word cross multiply. If I clear the fraction, I'm going to have 1 is equal to y e dot e raised to power minus y ln 5. If I divide both sides by e, I'm going to have 1 over e is equal to, this will cancel this, I have y e raised to power minus y ln 5. All right, I think if you have been following me carefully, you should know there is something I'm trying to drive at, because all this is to get to that point. I'm still going to hang you there. So let's click them. So I have, this is going to be y dot e is equal to minus y in 5 is equal to e raised to power minus 1. I'm sure you know what that means. I know, because this is something as e raised to power minus 1. So that was what I did here. So I'm going to multiply both sides by minus ln 5. So I'm going to have minus ln 5 dot y e raised to power minus y ln 5. I'm sure. Are you seeing what I'm looking for? E raised to power minus 1 dot minus ln 5. So I'm multiplying minus ln 5 on both sides. So that simply means I'm going to have minus y ln 5 dot e raised to power minus y ln 5. Because remember, multiplication is commutative, so this y can be moved to the front, which is the best form of writing a logarithmic function. So this is going to be equal to e minus 1 dot minus 5 ln minus ln 5. So at this point, I have got to one special function. Look at this. Let me rewrite it to make it look good. E raised to power minus y ln 5 is equal to minus ln 5 divided by, I'm sure you know that, because anything raised to power minus 1 is simply 1 over that. So that is why I'm here. So if you are watching this video carefully, you would have seen a lot of properties I have used in this video so far. Now we got to a point whereby something that looks like this has appeared. E raised to power x is equal to k. What property is this? Remember, it is called Lambert W function. And that is my intention all this while. But remember, I was given x in this equation, so I'm not going to use this. It is also the same thing as saying z e raised to power z is equal to, I can call it is equal to what? It can be equal to k. It is also Lambert W function. So Lambert W function is saying, is looking at something, the coefficient and the power. The same letter is the same as the coefficient and as the power. So whenever you have something, this is the z as the quotient and this is the z as the power. The law of Lambert W function says, in that case, you're going to say that z is equal to W function of k would be the answer. So look at this. He's saying that if you have, let's say P E P is equal to 5. He's saying that the answer is going to be P is going to be W function of 5. Now, this W function of 5 can be found in some special calculators, which is called a kind of product of logarithms. All right. So I am not going to speak much. So I have shown you what we are going to do. So we are going to apply them. Now, in this case, I am going to say that if my z is given as minus y ln 5, okay, so that simply means I'm going to say that z is equal to W function of what? Minus ln 5 over E. Look at what I mean. Look at what I mean. I have to, let me highlight it so that I see what I did here from here. Remember, if the sum letter is its power is equal to K, so the answer is going to be this S equal to the W function of this K. It's something, the whole of this is my Z. It's going to be the W function of everything here. So that was what I did. Okay. So writing it in a different form because I know what I called my W function. Therefore, I'm going to have that minus Y ln 5 is equal to the W function of minus ln 5 over E. That's not complete. Remember what I said from the beginning of this class? I have to find Y. Remember, but I'm not looking for Y, but let me show you what I will do. I'm going to say that Y bracket minus ln 5 is equal to W function of minus ln 5 over E. Good. So that simply means I want to have said that Y is equal to what? W function of minus ln 5 over E divided by minus ln 5. So for this reason, remember what my Y is. Let me show you. Let's go back. That was the place I told you what Y is. I said that, remember, Y is 1 over X. So I'm sure you have seen it. So in that case, I'm going to rewrite Y. So remember what we have Y is equal to, let me check what we have. W function of, okay, so it's going to be W function in bracket minus ln 5 over E, all divided by minus ln 5. Now remember what we said Y is equal to 1 over X. Therefore, I have 1 over X equal to W function minus ln 5 over E divided by minus ln 5. Now remember what this means. If 1 over X is this, that means X over 1 is going to be, let me rewrite this one. So it's going to be minus ln 5 all over W function of minus ln 5 over D. So this is the answer to this function. So all you need to do is, if you know, all you need to do, go to your calculator. If you have the W function calculator, all you need to do is to say X is equal to minus ln 5 all over ln 5 over E and its W function. Divide the two things. Whatever you have, you will have the value of X, which is around 3 points. Something sort. I'm not with this calculator right now. So this is the solution to this question. Thank you for being part of this class. And remember to hit the subscribe button and like the video. Have a nice time.